and solve your own problems. And we'll go through each step and we'll look at how to debug each step. So, let's do assignment 2. So, obviously there's no debugging in part 1. We discussed that in the first task, so we don't need to worry about that. Task 2, okay, the debugging is already written for you, okay? So you've got these checks here for you, and so you can debug this fairly easily. So part 2, we don't really need to look at debugging. Part 3, I've also provided you with the debugging. Okay, so you've got this little test here to test that it does actually remove the characters. Now, with this one, okay, how could we debug it if that's not working? So let's have a look at how we would go about debugging this particular function. Now, let me just grab a couple of little bits and pieces. That might make this a little bit easier. So I'm just grab the template. Where's the template? Assignment 2. Students. Cool. All right, so cool. All right, so with part 3, we've got some code that looks like this, and let's say it's not working. Okay, so the first thing that I would always debug is going to be what's actually coming into your function. Okay? And this is going to be important because obviously if you don't have the right values coming into your function, then it won't make sense. So for example, if your function is x, y, x plus y, and you pass in 4 and 3, but it's actually adding 2 and 1, you can see that there's obviously a problem. So the very first thing to debug would be what's coming into the function. Now I'm going to repeat myself quite a bit today because we want to make sure that we're debugging correctly. So first thing is I will debug this str, and we know that's a string, okay? And so I'll just print out str. I'll also debug num and just make sure that's also correct. Okay, so that's the first thing that you can check in terms of your logic if it's not working, is what I'm getting into the function, what I'm passing. Does that make sense? It only makes sense to one person.
Yes, it does.
Cool. All right. So, sorry, I'm getting messages all over the place. Yep, so AJ, this applies to you as well. You're saying you're not getting output, so you need to debug. Okay, so you can use the same skills. Okay, all right. So now what I'm going to do is have a look at the assignment sheet again. We discussed part 3 right at the end of the last session. We've got a for loop. Okay, so we've got a for loop, and we've got some I variable in here. Okay, Now, what you can do inside of this for loop is you can debug the iteration. And what this means is you're testing, does it go around a certain amount of times? So say you've got a function that's meant to sum up 4 plus 3 plus 2 plus 1, it should go around the loop 4 times, okay? So in my loop, if it only prints twice, I can work out that my for loop is the problem. It's not what's in it, but it's how many times it's going around that's the problem. So what I can do is I can put a print here, debug, I, set D, new line, I. Okay, so I can debug what's happening around the loop. If it goes on forever, then I've got an infinite loop. And that means there's probably something wrong with the condition. If I is not incrementing, so it's going 0, 0, 0, 0, then it's probably something to do with the update as well. Okay. If it's starting in the wrong position, so if it's going 2, 3, but it's meant to be starting at 1, then you know that the problem's there. Okay, so this is where you can extract this information. Now, in this function, string at index I becomes string at index I plus none. So this actually, so we've got some logic here. Okay, so we've got some logic. Okay, and what we can do is we can, before we do this logic, okay, we can see what the values are, and then we can test what they are afterwards. Sorry, so what I'm going to do is I'm going to do a printf, and I'm going to take my string. Okay. Oh, sorry. I'll keep it. I'll use the same format the whole time. So I'll take my string. I'll make sure what's happening to my string the whole time. Okay. I will take my string at index, what was it? I. Okay, that's going to be a character, and see what's happening there. Okay. And I'm going to see what's happening at string index I plus none. And then I'm going to do my logic, whatever you have decided for your logic. And then what I'm going to do is I'm actually not going to leave it like that. I'm going to go and copy paste this so that I can see what happens before and after my logic. Is my logic doing nothing? Is it changing something but the wrong thing? Oops. Okay. I can see what is happening to my logic at each step. Okay, so I can see what happened before and what happens after. Does string at index I actually become string at index I plus none? Or does it not? Okay, so this is the way I can debug it. Now, another problem. What if I get segfault? So segfault is a memory problem. So the very first thing you'll need to do is draw a box and pointer diagram. Then what you need to do is get rid of your logic. Okay, you need to get rid of your logic, just comment it out and test your I and see if it's going into somewhere that it shouldn't using your box and pointer diagram. And this is how we would debug task part 3. Okay. So this gives you all the tools needed to make sure that your task 3 works given any problem. Okay, you know what it's meant to do. It's meant to be moving them across. Okay, does that make sense? And I want a yes from everyone so that I know that everyone got it and everyone's still listening. Or a no. Okay, so that's how we debug this little function. Now we get up to part 4. And this one's a little bit harder to debug, okay? Because now we're dealing with memory. So there's a couple of good ways to check this works. And as it says here, for those students that have done this step, okay, all right, have done this step, you might want to double check it, okay? Just because it appears to work doesn't mean that it's correct, okay? So the way that I would check this is I would put really, really large reactants and products. Now our limit is 128. Okay, so our limit is 128. You might want to make that bigger, say maybe 256 or something, and enter every single one of these as 127 characters. So you can just do lots of A's, for example. Okay, so do A's up to 127. Okay, and then the null terminator will follow that. Okay, and do that for all 4. Okay. Then what we do, okay, now that we've done that, we then get our reactants and products, okay, and we allocate the memory for them. And because this is using a larger amount of memory, it's more likely to go into somewhere that it shouldn't if you've done it wrong. Okay? So using very small numbers, yeah, it might work quite often. Why is the eraser not working? There we go. It's more likely that it'll work more often, but to really test it, you'll need to run big numbers. But that's not all. So the next thing you'll need to do to test it is go and access that memory, because just allocating the memory isn't enough. So what you should do is once you've got these reactants, blah. Oh, I give you it. Okay, cool. Yep. So you've got the string copy, you've got the string cat, you've got the string copy, and then you've got this check. Okay. Now, once you add, so you actually don't need to test it yourself, which makes it really good. So once you've got these really large values, does it still print out here, or does it segfault? If it segfaults, how would you enter 127 characters without copy paste? Wow, why wouldn't you use copy paste? I just enter it. I just use copy paste. It's probably the easiest way. I think you've kind of answered your own question. Yeah, just so don't forget on the terminal. So actually know those solutions. I can do it on the server. Let me put it on the server just to make sure. Yeah, you can copy it to Unix. That's perfectly fine. So I'll just show you an example. So if I just write hey, copy, and to paste, I just right click. Okay, and it'll go into Unix. Okay, so if you ever want to paste, it's just right click. Okay, so now that's how I would test that one. And if you really want to test it, what I do is change the limit and bring it even larger. Okay, so maybe 512. Okay, if you really want to be sure that you're doing that malloc step correct, definitely do that. Now, the other thing you might want to do is see if this is successful. We talked about this in the video where you can add an if statement to check if it returns null. That might also help, okay, and it'll prevent you from segfaulting as well. All right, now we get to part 5. Now, I think part 5 is where a lot of people are finding a lot of problems. And this is probably one of the easier ones to debug. So let's go through this. All right, so let's grab the function. What's the function? Balance check. I even gave you the for loop. I'm so nice. Awesome. Okay. So there's quite a few things that we'll check here. Oh, that's not what I wanted to do. There's quite a few things that we're going to check here because there's quite a few things happening. Okay, so just give me a second. I'm just going to copy it across. All right. So the very first thing that if you're having problems and the easiest check to do is just go ahead and print all these out. Okay, make sure they're correct. Okay, if they're incorrect, then there's no point continuing. Okay, because if they're incorrect, then why are you looking in here? Okay, does that make sense? So you know how to do that. All right, you can do that with a whole heap of printfs. Okay, you've got this balanced number of atoms current element. The other thing you can check is your current element. Okay, so I would probably, if you're having problems, I would definitely put a printf here, and I'd put CentS. Oh, no, I put some kind of debugging. Now you notice that I'm writing D beforehand, just to indicate that this isn't part of the normal output, so I remember to remove it later. You can use macros guarding for this, but we're not doing that this year in the lab, so you don't need to worry too much about that. So current element. Okay, it's a string. Okay, and just make sure right at the start that the current element is the correct element. Okay, once again, there's no point looking in here if this is wrong. Okay, does that make sense? Have we still got other people listening? All right. So the next thing is that we've got the string length of the reactants. You've tested reactants. Okay, so you know how long it is. So if it's, let's say, so let's say it's A, B, C, D, E. Okay, so you know here that your current element should be A. Okay, and you know that this should go around a couple more times. How many times? So string length reactants is going to be 5 plus 1 is 6. Okay, so it's going to do it less than 6, and we've got I is 1. So we should get 1, 2, 3, 4, 5. Before you even put anything in here, if it's not working, just comment it out. Sorry. Just do a printf. Okay. Debug I %d /n I. Okay. Try that. It should print out 1, 2, 3, 4, 5. Try A, B, C, D, E, F. Should print out 1, 2, 3, 4, 5, 6. Add another one. Is it working? Okay. Is the loop working? This is how we can test the loop. Okay. All right. So we've got that, and you're happy. Okay. You know that the current element is correct. You've tested that. You've tested every single one of these. Okay. And you've tested that the loop is working. Okay. So if you're asking, if you're saying to me that it's not working, you need to check all these things first. Okay. This is part of it. Okay. This is part of the task. Okay. Is debugging and being able to solve your own code, know what's going wrong and right. So we know now that this part's working. Okay. I'm going to add my if, else if, else here. And you tell me that this isn't working. You tell me that this isn't working. Okay, it's not going into any of these. How would I test this? So I'm going to tell you a slightly better way to test this. And the way we're going to do it is we're not even going to worry about the file. So what you're going to do is going to create a new C file. Okay. All good with that? It's going to have main. Okay. And all you're going to do is printf, enter a car, scanf. We'll just call this car test. Okay, scanf, %c, address of test. Okay, why am I doing this? I'm isolating the whole test. All I need to see is, will it pick up a lowercase letter or will it not? Okay, so I'm just going to isolate this completely and just test, can I actually get a lowercase letter? And then I'll do my if statement. Okay, but instead of writing reactants I'll just swap that with test. So I'll have test something, something, something. Okay. And then I'll have a printf. Test is a lowercase letter. Else if. Test blah, 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 blah. Printf. Test is numeric. /n. Okay, so this isolates printf else. So this basically isolates any issue with reactants or any other variable in the program. We're just testing, can you get a lowercase letter? Can you get a numeric character? You're not worrying about anything else. You're just going to make a new file and just test, can you get a lowercase letter? Can you get a numeric? Does that make sense? Okay, so what I'm trying to show you here is different ways that you can test your code, test your networks, test your systems, test your engineering, etc. But for example, if you've got a networking problem, you might want to isolate that problem and deal with it by itself rather than trying to deal with it in a busy system. Okay? A lot of you are doing networking. You're probably aware of that. Okay? You don't want to be working in a busy system to test it. You want to bring it out, test it, and then put it back in the busy system. Okay? You don't want all that extra noise. Okay? So we just bring it out, test that we can do it, and now we'll put it back in. Okay? And we can test it again. Okay? So what we can do is now add our if statement again. Okay, and we know that it can pick up a lowercase letter. We know that it can pick up a numeric character. So we have our test, we have a printf here, and we'll just say lowercase. We'll say printf numeric. Okay, and you'll have your test there, and then you'll have your printf else. Okay, but this time, okay, you are not using test, you're using reactance I. Okay. Now, if this doesn't work, then it means there's something wrong with reactance I, because you know that the lowercase and uppercase and numeric works. So you can pinpoint that the problem is with the reactance, not with your conditions. Okay, so by isolating it, we don't have this problem of this pointer being passed in and not knowing what it is. Rather, we can isolate it and just deal with knowing it's a lowercase letter, knowing it's a numeric character. Okay, so once you've got that tested, so actually, before we do that, how would we test this? So the way we would test this, okay, so this is lowercase, this is numeric. So a lot of students, I notice, are going, this is the only test case. This is what I should test. No, okay? I wouldn't even bother looking at that, okay? Make your own test cases. That test case is bullshit because it's way too complex, okay? It's good for when you're finishing off, but it's crap when you're trying to just see if it works. So the reactants that I'd be passing in, okay? Okay, would be, I'd try AB plus CD, okay? And see if it prints else 3 times, okay? I would test lowercases. Okay, I would see, does it print 4 times? I would then test numbers. Okay, what am I doing here? I'm keeping it really simple, okay? I'm adding little bits at a time. I'm not going straight to this complex problem. And that will test if it's picking up lowercases or numeric. If it's only picking up the lowercase but not the numeric, you know exactly where the problem is. It's between these 2 braces. Okay, it's not inside of here, it's not up here, it's not down here. Okay? So we can work out where things are. Okay. We good so far? Is that making sense? Anyone else? Cool. is Amandeep. Is this making sense?
Yeah, all good. Yeah,
Cool.
I've got the similar problem. My number of atoms are I think they're not being converted to decimal integer.
Okay.
They're being treated as chars, which is why I had that problem that I told you about before on the email.
So the integers aren't being converted. Okay, cool. All right, we'll get to that. So that's, I think, the next step. So let's have a look. All right, where are we? So, all right. So now we're happy. Okay, we know that this works and this works. Okay, so we're just breaking it down and making sure everything works. Now you don't need to test everything. Okay, you test where you want to test. If this is working first time, you don't need to worry about it. But what we're doing is trying to find the problem. Okay, we're trying to locate using some common sense and some problem solving skills. So now what we're going to do is look at this. Okay, the second character in the current element becomes this letter. Okay, so this one's going to be fairly easy. We've got logic, and then we just do a printf of debug current element. %s/n current element. And that will tell you if your logic there is working. Okay, if it's got two characters, so if we enter AA, we should have a capital A and a lowercase a. BB, it should have an uppercase B and a lowercase b. Uppercase C, lowercase c. Uppercase D, lowercase d. Okay, we need to add some stuff to the else to reset it, but that doesn't matter too much right now. Okay, so this is assuming you've got the stuff in the else. Okay, but you can add that printf there. All right. So we don't quite know if that works yet, over and over again, but we should be able to test this AA. Okay, just a single AA. So the numeric character. Okay, so we need some logic calling the appropriate function. Okay, so we've got in our code this decimal to int, and we don't really test it. So what I would do, create a C file. Okay, int main. Okay, and then go to your code, go grab that function, go put it in there. Okay, and then printf, enter numeric car /n scanf %c. Let's just call it car user input, user input. Okay, so we're just entering a numeric car. We have a function prototype up here as well of this. I'm just doing the shorthand so that it's quick. Then I just int convert, something like that, and then I just go convert becomes numeric car to decimal int, and then take the user's input, and then print out convert. And just make sure that's working. You haven't accidentally made some changes to it. Okay, so this is convert. Okay, so that will test if you can convert a numeric car to a decimal int. Does that make sense? Does that help? Does that help you, Mandy?
Yeah, that makes sense. Yeah.
So I try and isolate it and just test it by itself to see if you can get that numeric car. Okay.
Yeah.
So once you've done that, we can come back to here. Okay. And then if I need assignment sheet. So blah, 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 part 5. All right. So in here, we can do that logic. Okay. So we can take that variable out. Okay. You can have another variable like I did in that example just there and just call it convert or something just for testing. You have number of atoms logic. Okay. So you have the conversion, you have the number of atoms logic. Now, these can be done in the one step, but if it makes it easier, you can do it in 2 steps. Okay. So you can create a variable. So say int convert, call the function, and then set the number of atoms. And then it's just a printf of that. Okay, number of atoms, %d/a. And that'll be number of atoms. So to test this, I would probably just do A2, A4, A2, A4 plus, A2, B4, C6, D8, or something like that. Okay, so just go across it. Okay, so we can test that. Okay. The else is print out the current element, okay, and the number of atoms. Okay, so there's already a check there, okay, and it kind of gives you everything. So print, check, we're doing current element and number of atoms. Okay, so it'll test all of that for you. Then set the number of atoms back to 1. Now I kind of give you the answer for this, okay, so there's not much to check there. Number of atoms, 1, okay, and current element 0 to reactance I, and the second character to null. So current element I is current element 0, sorry, is reactance I, and current element 1 becomes 0. Okay. So, has anyone got any problems that are outside of that scope of what we've covered and how we would test it? Is there anything that we haven't tested there? Anyone? Or is that making sense, how we're testing it? So we're trying to just test each individual part. We can just break it apart and try and find those problems, and we can isolate the programs. And these are just throwaway programs, so they don't have to be perfect, they don't have to be invented, they don't have to be anything. We just want to make sure that the little bits work, and then once they work, we can just chuck them into our program. Don't try and, so with engineering, with IT, with any system, okay, one of the biggest problems I see, okay, is Photoshop not working, okay? This is just made up of little blocks, okay? The little blocks are nice and simple and easy. This looks scary, okay? Tackle these, putting them together will make this, okay? All right. And this is what makes us as engineers and computer scientists and ICTs the experts, because we know where these little pieces fit in and how they work, okay? We're not experts because we know every giant system, okay? It's just impossible, okay? We're experts because we know the maths and the little bits of pieces and how to put them together. All right. Is there any more questions about step 5? Or does that all make sense? So that all made sense. Just say all good, and then we might have like a 5-10 minute break, and then we'll go have a look at step 6 and how we debug that. Good. All right, so we'll have a, what's the time? Okay, so we'll come back at 7, all right? So come back at 7. Hopefully this is helping you solve your problems whilst also teaching you how to solve them. Okay, all right, so we'll come back at 7. Let's have a quick break from talking. All right, so where are we? Step 6. So this one we have quite a few steps. We have quite a few ifs and elses. And this is a really nice one to debug because we do have all these if, elses and stuff. So let's have a look at it. Let's look at how we debug it. And we'll look at taking certain bits out and isolating them. And we'll also look at how we can debug it, because this one's going to start getting a little bit more difficult debugging. So we've got something like this, but don't forget we also have this. So the very first thing I'd always do is just check that you're getting the right data. You can do this before the function or in the function itself. It doesn't really matter. But it is a good idea to do this, especially with pointers, just in case you are sending the wrong thing across. So the very first thing I would check if you're having problems is going to be do a printf and just check that string, that int, that string, that string, that int, and that int are correct. It'll also help in your debugging because we'll know what we're currently looking at. Okay. So now let's have a look at each stage. Okay. So the first if statement tests if it's in the first half or in the second half. Okay. And the way that I would test this is just by passing A, B, C, D, go through each one. I wouldn't worry about any of this, okay? I'd just print F. Sorry, this is first. Print F first. Print F second. Just comment everything out and just make sure that's working, okay? So that will check if that 1 is working, okay? So if you're unsure and it's not going to the second half, so maybe that's the second half, that's how you check that. So just comment everything else and just have an if else and just check if it's the first or the second. As simple as that, okay? So that's how we check 1. Does that make sense? Still got people here? Can you hear me? Cool. All right, so don't try and do everything at once. Try and focus on it and just try and work out if it's the second or first. Just test that one and make sure that one works. All right, nice and easy to start with. Then what have we got? The current element is part of the second. Okay, so we can test the second just by itself. Okay, so I would try and pass in, doesn't really matter what's in the first. Once you're happy that it's passing in the second, then I would just start playing around with the second. Okay, so I would do something like AB, AB plus, let's say, C2, D2, okay? And inside of 2, I'd have my logic and I'd print the total number of reactant atoms current element. And because we have no coefficient, it should just print out 2 and 2. Okay. Once you've done that, I would add a coefficient, so say 4 there, okay? And then I'd make sure it prints out 8 and 8, okay? Now, this is really important, and the reason this is the second step, okay, we haven't put it right at the end, is because this is much easier to debug if we're just looking at the second half. Once we've got the second half working, then we can worry about the first half. So I wouldn't worry about any of this until you have the second half working. So I'd try, so put a print here, okay? Definitely put a print to print out the total number of reactant current element. Okay, and the 2 tests I would do, actually I'd probably do 3 tests. I'd probably do AB plus CD, and that should give me 1, 1. Then I'd do AB plus C2, D2. That should give me 2, 2. And then the third test I would do is 4, C2, D2. And that should give me 8, 8. And I might do one more test just to make sure that it is actually going to test more than 2 things. So I might do E here as well. Okay, and here it should print out 8, 8, 8. Okay, so that's how I test that. And I just comment out everything after that. Okay, I wouldn't even bother looking at this. Just look at the second half and make sure the second half works. So we know that 1 works. We've already tested that. And then I just focus on the second half. Does that make sense? Okay, so what I'm doing is just isolating different parts of the program so that I know that this works. And once I know this works, it's going to be really easy to work out if the second half works. Okay, the first half. The second half is actually the easier one rather than the first half, just because of the order that we search through it. Okay, all right. Now I've scribbled all over it. I might put a new one on, or I could do that, or I could just erase it. So let me get rid of all this. So now we know this part works. Okay. Yeah, you can test small letters as well. I'm not too worried about that in this one because the number of atoms has passed anyway, and we've already tested the lowercase letters. I will worry about lowercase letters a little bit later. Definitely, there's no harm in adding some more test cases though. So yeah, you don't have to ask, can we? Do whatever you want to test. The more tests, the better. The more you test something, the more likely it's going to work always. Okay? If you give me something that's been tested 10 million times and you say it's worked every single time versus you say to me, you've tested it 10 times and it works every single time, I'm going to trust it more if you've tested it 10 million times. Okay, so let's keep looking. So now we're going to look at step 3. So the current element is part of the first reactive. Now, remember that we 100% guaranteed that part 1 works. And we're 100% guaranteed that part 2 works. Okay? So now we're going to go to part 3. So we need to check if it's also in the second reactor. Okay? And we create a pointer to a car named location pointer and store the result using string and passing the address of reactants 1, length, and the current element. Okay, so that's a lot to take in. So what we might do is do what we did before and isolate the problem. Okay, so oh, go away. All right. Sorry, I've got 10,000. So we're going to isolate this problem, and we're going to use a new file. Okay, and we're going to just create a main. Okay, and we'll create a string. Okay, so we'll call this test or something. All right, and maybe we'll make it 8. Okay, and we'll do A, B, C, D. Let's say A, E, F. Okay, so that's my string, and then I'll have my int. What's the thing called? Reactor 1 length. So I'll just call it R1 length. Remember, these files for our testing are throwaway. Okay, and I might decide that the length of the reactive 1 is maybe, let's say this. Okay, so we'll say it's 4. Okay, now this file allows me to test a whole heap of combinations. Okay, and this is what I'm trying to do here. Okay, I'm trying to see if I can pick this up, and we'll do what was suggested before by I don't know the name. It's just a student number, but one of the students mentioning testing with lowercase letters. So we're going to include the string library, okay? And we're going to test this str. So what we're going to do is, what we'll do is we'll grab our, what have we got? So we'll create a car pointer, call it, I think we had called it location pointer. And we'll call this str, and we'll test it, okay? So we'll go from, it's an address, so we're passing the address of test, and we'll decide that it's from R1 length, okay? And we'll try A, okay? And then what we'll do, okay, is we can go printf, centS, block pointer. Now, this isn't going to print out A, okay? Actually, we should probably do this. We probably should test if it's null before printing it. Actually, yeah, we should. If block pointer not equal to null. All right, so printf null. And in here, I might just do printf centS /n location pointer. And what this should print, if it finds it, it should print AEF. Okay? Then what am I going to do? I'll move this. So I'll now make it 3. This shouldn't change. Okay? It still should print out AEF. It should find a pointer to A. Okay? But it's printing it as a string, so it'll keep printing everything. Okay? And then I might try it with a smaller value, or I might change some of these around. So I might write EFA. Okay? And I will test, does it find this, and does it now print A? Okay, because it's right at the end. So this is how I'm isolating this and testing that this string works. Okay, does that make sense? Everyone in the chat, you still here? I scared everyone off. Sandeep? Still here, or you just left? Cool. Okay, so this will allow us to test if our str is working. Okay, so that's isolated it. Okay, so we're using our debugging techniques. We're not guessing, we're not just following steps. We're trying to be professionals. Okay, so now what we're going to do is we'll implement this here. Actually, there is 2 A's. There's one here, one here. If there's 3 A's, it'll never happen. It's part of the constraints. Remember what I said at the start. The most important thing is to read the background information. Okay? An element will not appear twice in a single compound. So there can never be 3 A's. It's impossible for this problem. Does that make sense? Cool. All right. So now what we can do is in here, in this 3-part, remember that we don't care about any of this. Okay? We don't want to confuse ourselves. We want to make sure this works 100%. We don't just want to test it on the shitty examples that are given on the sheet. we want to actually test it on lots of examples, okay? We want to make sure that each part works 100% because I'm probably going to just run this through a tool that tests it maybe 1,000 times, okay? It's not going to be the 3 tests on there. I'll just make a tool that'll test it 1,000 times, okay? So if you're 100% sure that it'll work, you have nothing to worry about, okay? All right, so where are we at? All right, so if it's part of the first, okay. So what we can do here to debug this is printf, %s. Now, with our debugging, we need to just check if it's null first or else it'll crash. So just be careful about that, okay? When debugging the location pointer, you need to be really careful because if it's null, it will crash. So you need to check if it's not null before you do the printf. Okay, so this is inside step 3. We haven't done any of this. Okay, this is all still gone. Okay, we're not even worrying about the if statement or anything. We're just testing the location pointer. And what this should do, so we're going to do some nice simple tests again. So we're going to test AB plus AD. When it runs through this, it should print AD. Okay, it'll just continue printing till the end. And then we can try AB plus DA, and it should print A. Then we can try something like AB, AB. This time it should print AB and then B. Okay, so like we did last time with these test cases, here we should get AD, we should get A, here we should get AB, and then we should get a B, okay? Because remember the location pointer will just go to that location. Then we can try some things more complex like AAB plus AAB. This should print out AAB and then B, okay? Once you're happy with that, we've 100% ensured that that's working. Okay, we don't have to worry about that. Now, if that's working, this next part should work. Okay, so what we're going to do is we're going to go in here, okay, and do this number 4. So like before, okay, what we're going to do is not worry about any of this, okay? We don't care about it, all right? Just gonna get rid of it, all right? Because it doesn't really matter, okay? And all we're gonna do is we're gonna get a big print and say in second as well, okay? Exclamation mark. Not in second, in the else. And test it on a whole bunch of simple examples like these, okay? And make sure that this not null actually works, okay? Once you've done that on a couple of examples, 4 is 100% guaranteed then, okay? So we're guaranteeing that we don't have to worry about these things, okay? You'll notice that we're not writing the whole thing and then crossing our fingers and then hoping it works. We're going through this slowly. Does that make sense up to this point? So basically, with the program so far, in the way that we've tested it, all the steps we've done so far, we know that they're going to work not 1 out of 10 times, but 10 out of 10 times. Okay? We might have forgotten some cases, so it might not work 1 out of 100 times, but we're pretty happy with where we are. Okay, does that make sense? Are we all still here?
Yep, all good.
All good? Awesome. All right. Cool. The next step is step 5. So the next step is step 5. Now here, what we're going to do is completely ignore steps 6, 7, and 8, and 9. If you've already written them, just comment them out, okay? So we don't care about them. So step 5 is store the string length of the current element into a variable. Now this one, at this stage, if this doesn't work, I'd be worried because we've been using our current element the whole time, but still, just in case, do a printf, %d, and check. So whatever value, so what do we call it? Length of element 2. Okay. All right. So here, all you want to do is remember that this is ones that have a second part. So it's going to be these ones that we're testing. So here, if we pass AB, AD, okay, it should give us a 1 because the length of our element is 1. And the other one I test is AB, AD, and this should give us 2. Okay, they're really the only tests we need to do. Okay, you might want to do one more test where you test something like this, maybe, and then you get 2, 2. Okay. That one's fairly simple. It should already work, given that you've got the other stuff working. Okay, because if that was wrong, then I'd imagine that the stuff earlier would have been wrong. So that one should be a fairly easy one to confirm it works. Okay. So now what we're going to do is, so we're happy with that. Now we've got step 6, 7, 8, and 9. So step 6, we then check if the current element in the second reactant is followed by a numeric character. So this if statement here, we might not actually want to do yet. And I just did that. So I'm actually not going to do that yet because I'd like to know that I can actually get it before putting it inside of an if statement. So what I'm going to do instead is I'm going to try and get it. And the way I'm going to do this is I'm going to use some logic that we discussed in the previous video. Okay. And then I'll just do a printf here. Okay. And what I'm going to do is I'm going to print that. Oh, it's a character. Oh, shit. Wait, when is character? Yeah, it's a character. So all I'm going to do is I'm going to print that character that we get from that logic. Okay, so I'm going to get the character that follows. Okay, and I'm just going to print it out. So I'll just call it follows. Okay, you can call it whatever you like. Okay, it's just a dummy variable that we'll get rid of soon. So all we're trying to do here is if we've got AB, AD, it should give me the D. If I've got AAB plus AAD, it should give me the D. And if I've got AAB plus AA4D, it should give me the 4. So I'd run these tests and make sure that it gives me the letter after the element. Okay? So they're the tests that I would do. And they're the expected values. So D, D, 4. Sorry, I should have put these in red as well. Okay. So I'd make sure that I can get that number afterwards. Does that make sense?
Yeah.
Cool. So now we've done that, we can add that into our if statement. And what I do now is I would, inside of 7, okay, inside of 7, and inside of 8, inside of 9, I would basically do just a printf, okay? Printf numeric, printf non-numeric. And I just run these exact same tests again, but this time it gives non, and numeric. Okay, so that would test that. Once we've done that, we're pretty happy that step 6 works. Okay. So what I'm doing here is I'm just confirming that this whole thing is working. All right. So all right. So now what I'm going to do is I'm going to look at step 7 and 8. So 7 and 8, because we did and we confirmed step 2, 7 and 8 should be fairly easy to confirm. They're going to be very similar to this. So we just do the same thing that we did before. We just print out the values, okay? And we can try something like this, but with the first half, okay? So that gets us that, and then we've got step 9. And step 9 is probably one of the harder ones to test because it's removing the characters. But you've already tested this, okay? You've already tested this in the previous one, and this is why we took the test out. Because this one's actually pretty difficult to test inside of the function itself, we took the testing out and we did it in main, okay? Remember we did the hello and allo, I think, no, it was low, okay? The reason I got you to do that there is because it's pretty hard to test there. So if you did it correct there, then it should work here, okay? And that is how we debug the whole thing. Oh, step 10, or step 10, step 10. Oh, step 10 is the same as these ones. Okay, so sorry, I should have looked at that. Step 7, 8, step 2, 7, 8, and 10, you test all the same way. Okay, it's just getting the correct value. And I just try a whole heap of combinations like what I did here. Is that all good? Does that all make sense? So I think that'll give you a good indication of how to make sure that everything works in your program. Okay, it might look like a lot, but remember, these tests take seconds. It doesn't take hours to do. Okay, just quick test, printf, printf, printf. Run it a couple of times. It looks like a lot when you go through it, okay? But when you're actually doing it, they're really quick and really easy, okay? And it means that you don't have to go back. So, for example, let's say I didn't do it this way. Let's say I just wrote the whole thing and my problem is here, okay? It could take me hours to find a single character in thousands of characters, okay? For example, if I give you this page and I say, where's the spelling mistake? It will take you a long time to find, okay? But after every sentences, if you tested it, then it'd be easy to find, okay? By breaking it up, we're actually making it really quick for ourselves and we don't have to go back and look for tiny little mistakes, which might take hours to find. And this is the reason we get you to do it this way is because it's actually quicker. It's a lot quicker. All right, hopefully that was helpful. I've recorded that, so if you want the recording, it will be available. It'll probably be ready tomorrow, maybe. And yeah. Hopefully that was interesting. I might end it there, unless there's any other questions. That's all right. Hopefully that helps. All good. Yeah, so I'll upload it to YouTube. So if you just check my YouTube page, it should be up there, and then eventually I'll put it up on LMS. Yeah, so that, and this is the way you should approach step 7 as well. Okay, so I'm going to stop the recording.